Today we're going to go on and look at using upper and lower bounds in calculations. But before we do that, we're going to just have a look at some facts, really, if you like, about adding, subtracting, multiplying and dividing. Okay, first of all, let's have a look at adding. Okay, and I'd like you to look at this table here. In section A, there are 4 numbers, 1, 2, 3 and 4. Section B, 4 numbers, 5, 6, 7 and 8. And basically you have got to combine A and B by adding, subtracting, multiplying, dividing to get the biggest and smallest possible answers. So first of all, let's have a look at the maximum value of A plus B. Now that's the upper bound. So what is the largest possible value you could get if you were adding an A to a B? Well, it's fairly obviously going to be the biggest A and the biggest B. Okay, so that would be 4 plus 8, which is going to give you 12. Okay. To find the minimum value of A plus B, so I want one of the A's and one of the B's, well, the only way I'm going to be able to do that is do the smallest of the A's, which is 1, add the smallest of the B's, which is 5, so that's going to give me 6. So the upper and lower bounds for adding are 12 and 6. Now let's look at multiplying. If we're going to multiply two numbers together, I'm going to multiply an A number by a B number. Well, to get the maximum value, the upper bound for A times B, I'm going to do 4 times 8. Okay, so the biggest A times the biggest B, which gives me 32. And if I want to find the minimum value of A times B, so for multiplying, I'm going to do the smallest A multiplied by the smallest B. So 1 times 5 is going to give me 5. Okay, so notice for adding and for multiplying, okay, if you want to get the biggest possible value, you use the biggest numbers. If you want the smallest, you use the smallest. So adding the biggest and adding the smallest. Okay, but let's have a look at subtracting. Okay, so we're going to do B take away A, and I want to get the biggest possible answer. Well, to do the biggest possible answer for B take away A, I'm not going to do 8 take away 4. I'm not going to use 4 and 8 because 8 take away 4 is 4. But if I do 8 take away 1, so the biggest B take away the smallest A, so 8 take away 1, that's going to give me 7, which is the biggest number I can get. Whereas if I want the smallest value of B take away A, okay, if I do the smallest B, so if I do 5 take away 4, okay, 5 take away 4 is going to give me 1, and I can't get anything smaller than that. Okay, if I do the smallest B, take away the biggest A. Now, when I'm dividing, okay, this is a bit more difficult because we're thinking of fractions here, but you will see that actually for dividing, it's the same as for subtracting. If we want to get the biggest possible answer for B divided by A, well, I'm going to do 8 divided by 1, or 8 over 1, which is going to give me 8. Whereas if I want the smallest value, or the minimum, or the lower bound of B divided by A, I'm actually going to do the smallest B, okay, divided by the biggest A, so 5 divided by 4, which gives me 1 1/4, and I'm not going to be able to get anything bigger than that. So whereas for adding and multiplying, I just have to add and multiply, or multiply the biggest numbers, I have to be careful when I'm subtracting or when I'm dividing. So for the biggest, I actually do the biggest divided by the smallest, and for the other way round to find the minimum value. Okay, just bear that in mind for later on today. Okay, let's have a look at the idea here. So a book is 4 centimeters thick to the nearest centimeter. 100 books are placed in a pile. What is the minimum possible height of the pile? Now, what you must understand here is that you don't just do 100 times 4. Okay, what you have to do first is you have to take the measurement that you've been given, which is approximate, and you've got to find the upper and lower bounds for that. Okay, so think about that book, 4 centimeters thick to the nearest centimeter. So remember, that's to the nearest 1 centimeter. The upper and lower bounds, then, to find them, we're going to add and subtract 0.5 centimeters. Okay, which means that the book, and you can write it as a thick, you can write it as an inequality if you like, or you could just write down the biggest and the smallest. The maximum thickness of one book is 4.5 centimeters, and the minimum is going to be 3.5 centimeters. You've done lots of these now. So if you wanted the minimum possible height of the pile, well, that would assume that every single book is its absolute smallest. In other words, it's 3.5 centimeters thick. So you would now do 3.5 multiplied by 100. Well, that's going to give you 350 centimeters. or if you like, 3.5 meters. Okay, to find the maximum possible height of the pile, assume that every single book is as big as it could possibly be. Well, that's 4.5 centimeters. Again, there are 100 of them, so actually that's 450 centimeters or 4.5 meters. Okay, so the most important thing here is to write the upper and lower bounds for the measurements that you've been given first, then do any calculation. Okay, so slightly more difficult problem this time. You've got a rectangle which is 8.64 centimeters long and 4.75 centimeters wide. Okay, and both of those are measured to 2 decimal places. Now remember about decimal places, 2 decimal places is, so 2dp is exactly the same as rounding to the nearest hundredth or to the nearest 0.01. So if you want to if you want to find the upper and lower bounds, you're going to add and subtract half of 0.01, which is 0.005. Okay, so let's have a look first of all at the length of the rectangle. So the length is given as 8.64 centimeters. So we know that the length is between its upper and lower bound. So the maximum is going to be 8.645 and the minimum is going to be 8.635. So that's adding and subtracting. Let's just write centimeters. That's adding and subtracting 0.005. Okay, the width of the rectangle is going to be in between. So we've got 4.75, adding and subtracting 0.005. So the maximum is 4.755 centimeters, and the minimum width is going to be 4.69. No, I can't do it. Sorry, brain got a bit scrambled then. So it's 4. Hang on. So 4.745 centimeters. Okay, now think. Area of the rectangle. So we want upper and lower bounds for the area. Now remember, to find the area of a rectangle, we multiply the length by the width. So if we want the upper bound, so let's go for the biggest first, the upper bound for area, okay, we're trying to find the maximum possible value of length times width. As we learned before, that just means we multiply the biggest length by the biggest width. Okay, so we're going to do the biggest length, well that's 8.645, multiplied by the biggest width, well that's 4.755, and that comes out as 41, where are we? So 41.106975. You might be asked to round this, but I'm not going to round it. I'm just going to leave it like that. Okay, if we want the lower bound for the area, well, that's going to be multiplying together the smallest length by the smallest width. So the smallest length, well, that's 8.635, multiplied by the smallest width, well, that's 4.745, and that comes out at 40.973075 centimeters squared. Okay, now we need to think about how to find the perimeter of a rectangle. Well, if we think about a rectangle, I'll just draw a little rectangle down here. Okay, you have got the length and the length and the width and the width. And to find the perimeter, you do 2 lots of the length plus 2 lots of the width. Now again, because we are multiplying and adding, we just need to use the largest values to find the maximum. Okay, so to find the maximum, so upper bound, sorry, for perimeter, okay, we are going to do 2 lots of the biggest length, so that's 2 lots of 8.645, add 2 lots of the smallest width, sorry, the biggest width, which is 4.755. If you work that out on the calculator, I'm sorry, that's 8.645, and if you work those out, it comes out as 26.8 centimeters. Now, if you want the lower bound for the perimeter, so lower bound for the perimeter, Okay, you're going to have two lots of the smallest length. Well, that's 8.635 plus two lots of the smallest width. Well, that's 4.745. And if you work that out on your calculator, it comes out as 26.76 centimeters. Okay, last example here. You have got a distance and a time, and both of those have been rounded. Okay, so let's find upper and lower bounds for the distance and the time first. Okay, so the 100 meters has been measured to the nearest meter, so to the nearest one. So for that, we're going to add and subtract 0.5. Okay, so the distance is between a maximum of 100.5 meters and a minimum of 99.5 meters. Okay, the time, 13.4 seconds, is to the nearest tenth, so that's to the nearest 0.1. So we're going to add and subtract 0.05 for the time. So the time, I'll use T for time, has got to be greater than or equal to 13.35 seconds, and it's going to be less than 13.45 seconds. Okay, now let's think what we're asked to do. We're asked to find the maximum possible speed, and in order to do that we need to know the relationship between speed, distance and time. You might know it using the DST triangle, so there's DST. So to find the speed is distance divided by time. Okay, so if we want to find the maximum possible speed, we're going to try and find the maximum possible distance divided by time. But remember that first slide from today. It's going to be the maximum distance, okay, divided by, to get the largest possible answer, we divide by the smallest possible time. So the maximum distance divided by the minimum time. Well, the maximum distance, and if you think about it, if you were running a race and you wanted your speed to be written down as fast as possible, you'd be going as far as possible, as far as you possibly could, in the smallest amount of time. So it makes sense, doesn't it? So you're going to do the biggest possible distance divided by the smallest possible time. Well, that's the 13.35. And if you work that out, it comes out as 7.528. I'm going to round it to 4 decimal places because I can't fit it in. Okay, right, if we want to find the minimum possible speed though, or the minimum possible speed, you're going to be dividing the minimum distance. We've still got to do distance divided by time, but you're going to divide the minimum distance by the maximum time. So you're going to divide the lower bound for distance. Well, the lower bound for distance was 99.5, and you're going to divide that by the maximum possible time you ran it in, which is 13.45 seconds. They're not going to be wildly different, but let's work them out. This one comes out as 7.39769, which I'm going to round again to 4 decimal places, 7.3978 meters per second. Sorry, I should have said meters per second. Meters per second there, and meters per second here. Okay.